Okay. Hello, this is Max, working on full 2014 final exam, question 5E. Almost done. Alright, the question is asking us to implement fib sums, a function that takes positive integer n and returns the number of ways that n can be expressed as the sum of unique Fibonacci numbers. Assume that fiblink is implemented correctly. Alright, so fib sum, number of ways, blah, blah, blah. And what do we have here? So we're going to have some total, some n, and some fibs. And what does this actually mean? Okay, so we call it, we're making a fib link, which is going to have, if you remember, up to is going to construct a set of Fibonacci numbers that are all the Fibonacci numbers that are less than or equal to the n that you pass in, so up to n. Alright, so it's sort of like, this is looking a tremendous amount like count change from lecture. And so I think we're just going to approach it like count change. We'll sort of think about fibs here. This is going to be, if I pass in like 5, this is going to be like 5, 3, 5, 3, 2, 1. Let's pass in 9 because that was the question that we used. Pass in 9, we're going to get 8, 5, 3, 2, 1. And so you can sort of think of this as like your coins here. And this is your total, the total that you're trying to make change for. And if you remember from count change, we have a success case, right? So our success case is right here. We've successfully broken apart. We've successfully made change, right? We've used some combination of coins to bring our n, our total, down to 0. And in which case we're going to return 1, meaning this is one successful way to make this work. Otherwise, we need to consider a failure case, which is this return 0. And our failure case here is, well, okay, so we could run out of coins and still have a non-zero total. So let's think about that. So fibs is a linked list, and so we should be able to do fibs equals link.empty. It'll be clear in your study guide how to actually do this, and so this might be a little bit wrong. But the gist is, you want to make, if the link is empty, then you've failed, right? You have run out of coins, and so we want to say that this is not successful. Or if you've overshot, so if n is less than 0, then this is also not a good way to make change, right? Because we've given away more money than we originally took in. And now sort of we have two cases, right? Our first case is, when you thought about count change, we could either use this biggest coin, or we could forget about it and try and make change with our remainder, right? So that's pretty much exactly what we're going to do. So if we use the biggest coin, we're going to subtract from our total. And so we'll make a recursive call to sums, right? Sums is our count change or our partitions thing from partitions, if you remember that. And we'll say n minus fibs dot first. Alright, so this is saying, okay, I'm going to use my biggest coin. And if we're using our biggest coin, one thing about this problem in particular is that we say it needs to be a combination of unique Fibonacci numbers. So if we've used our biggest coin, then we can't use our biggest coin ever again, and so we need to do fibs dot rest. So now we're considering all other coins that are not that biggest coin. We're trying to make change for 1 from 5, 3, 2, and 1. And we'll be successful only by using the coin 1, which is this case right here, which we've covered. Okay, cool. Well, what's the other case? So the other case is we decide not to use the biggest coin. We'll just try and make change on our own. We don't need that biggest coin. We are strong and independent. And so in this case, we're going to say, okay, I'm not going to use 8. I'm going to try and make change for 9 with just 5, 3, 2, and 1. And here we're going to use 5. We'll get down to 4. And we'll have 3, 2, and 1 as our coins. 3 is not going to work. And we'll find that, 3 will work. We'll get down to 1. 1, and we'll just have 2 and 1. And we'll find that 1 minus 1 is 0. And so we'll get this case right here as well. Okay, so count change, super important. If you don't understand it, then it's really worth taking the time to go back at lecture and understanding count change, because it's appeared twice in this exam and it's likely to appear again. So anyway, yep, go ahead and do that. And please post any questions on Piazza or YouTube if you have any questions. I'll be happy to answer them. Thanks for watching.